Okay. So, what is a firewall policy? So, policy is nothing but a definition on which says what traffic we have to allow and how to process the matching traffic. So, it basically says what traffic to allow, and second part is how to process the traffic. Now, if I am to define what traffic to allow, how can we define a traffic in a typical TCP/IP network? So, when we say TCP/IP network, the first definition which we can give is based on the MAC address, and the second definition we can say we can also define based on the IP address. Then we can say we can define based on TCP or UDP services, or we can also call it as port numbers. So these are the options available for us from the TCP or IP layer stack, where we can define what traffic it is. We can define traffic in using these methods, and then comes how to process the traffic. When we say how to process the traffic, in this part we will define about the UTM profiles. It can be antivirus. One moment, let me disable that or not. Okay. Okay, so how to process the traffic is where we will define what kind of security profiles we are going to apply on the traffic or allowed traffic. So in this comes the UTM like antivirus, then we have web filters, we have IPS, and so and so. There are so many other filters like VoIP profiles, video filtering. So we will discuss about all those things in detail in the upcoming part. So basically, the security policy is divided into two parts. One is what traffic to allow, and the second part is how to process the traffic. So this is what we are going to discuss today. And once we decide this, what traffic to allow and how to process the traffic, then we will set the condition where we will either allow or we will deny the traffic. Now, what will happen if all that we have created like hundreds of policies, and for some reason, maybe one of the traffic is not matching with any of the policies which we created. In that case, firewall will have an implicit deny policy which will match it, which will deny the policy traffic. So this is the basic idea about like what the firewall policy is in our firewall. Now, what based on these policies, we have to we can also take an action on the traffic. One of the important action is which we have already discussed, that whether NAT is allowed in the traffic or not. So we have seen in previous classes that the NAT configuration is kind of sandwiched with the firewall policy. So based on the firewall policy, we will define whether the NAT on the traffic is allowed or not. So if and with respect to NAT, the policy, the traffic can kind of match multiple policies, which we will cover later, where we will see after translation, the traffic will again go for one more policy lookup. And then at that time, the traffic may be might match different traffic. So that is a corner case, which we will discuss in later part as well. So now next important question is how this traffic matching is done. So firewall performs a matching from top-down approach. So if a match is let's say we have like five policies arranged in the order of 1 to 5. And if the traffic is matching with policy number 3, it will not go for another lookup with policy 4 and policy 5. Once the match is found, the process will stop there. So, and if there is no match found, let's say we have policy number 1, which is allowing, let's say FTP. Policy number 2 will allow DNS, and policy number 3 will, let's say, allow UDP 500 traffic, and policy number 4 will allow TCP port 80 traffic. And let's say the 5 is implicit deny. Let's say we have arranged policies in this way, and then we are receiving a traffic which is TCP on port 443. Now, this particular traffic is not going to match with any of these four policies. So obviously, the traffic is going to be blocked by implicit deny, and the traffic will be dropped. Now, let's say instead of 80, if we have 44, along with 80, let's say 443 is also being allowed in this. Now, the matching criteria will stop the lookup at this stage because this policy has been matched. So it will not go for another policy lookup. Now, this point is very important because when we create multiple policies in our firewall, we need to make sure that the specific policies are always on top and the granular policies should be always at the bottom. The reason being, let's say if I have another policy at the top which allow TCP all connections. Now this might match my 443 connection, and because of this, my policy number 4 will never take hit because all TCP connections are allowed by the first policy. So for this reason, we need to keep this in mind, that the specific policies has always to be on the top and the granular policies should always be at the bottom. The broad or wider policy should always be at the bottom. Now in FortiGate, you will get so many options in our firewall policy to be configured. So we call them as objects used by policies. So all references in FortiGate is referred as objects. So what are the common objects which we have in FortiGate? Let's take a look at those. So the first is the interface and zone. So this is something which we will configure, and please don't confuse this zone with other vendor firewalls like Palo Alto. In Palo Alto, the zone is something different where you will define inside or outside, but in FortiGate, we don't have such concept. In FortiGate, a zone is nothing but clubbing together multiple interfaces so that you don't have to select multiple interfaces in policy. Instead of that, you can select a zone. And second is address, that is source or destination IP address, then the user and ISDBs. So yesterday we had a discussion on what is ISDB. So I hope you have a clear idea on that. Then is the service definition. Then is the schedules. NAT rules, and then comes the security profiles. So these are the objects which we will commonly refer in our security policy. So we will take a look at this policy, these objects one by one. And another important thing, there are certain types of policies available in FortiGate. So let's take a look at what are the policy types we have. So I believe everyone is aware of about the first policy, that is firewall policy. Now this can be IPv4 or IPv6. We have to create separate policies. IPv4 policy will not allow IPv6. We have to enable the feature. Only then IPv6 policies can be created. Then comes the firewall beware policy. So we have discussed about this virtual wire on our first day. So beware has if we have configured or if we decided to put our firewalls in beware mode, then we have a separate policy definition for this. This traffic will not match with regular firewall policy. The reason being, VWire is something which is not applied on the entire VDOM or the entire firewall. But on the other hand, transparent mode is something that is for the entire firewall or VDOM. For this reason, to differentiate the traffic between VWire and regular traffic, we have two different set of policies, one for regular firewall policy and one for the VWire policy. Similarly, it has IPv4 and v6. Then we have proxy policy. So proxy policy is something which we will use if we have configured the firewall to behave in explicit proxy mode. So it's not very much different from the regular firewall policy, but the only difference is proxy policy will do authentication here. Even regular policy will have some part. It does play a part in authentication, but it's not the same as proxy policy. Proxy policy will give much more granularity. Then we have multicast policy. So multicast, as the name suggests, it's for the multicast traffic. So if we want the firewall to process multicast, then we have to enable this particular feature, and then we will get the option to create these policies. There are two modes for multicast in firewall. One is forwarding mode, where the firewall will not actively participate in multicast, where you will only you will define whether to allow or deny multicast traffic based on a policy. And the second mode is where the firewall will actually participate in multicast, where firewall will behave as a RP if needed, and then it will allow or deny the traffic based on the requirement. Then we have local in policy. So local in policy is to control all the local traffic coming to the firewall. So we can also define that. Then we have DOS policy. This is to prevent DOS attack. And at last we have traffic shaping policy. So traffic shaping will come in only if we want to use QoS, if QoS comes in picture. So at this part, we will use traffic shaping policy. Now, in our discussion, the main focus for the day will be on the firewall policy. We will discuss the other policies in later part, because firewall policy is something which is needed for the traffic to be allowed or denied. So let's take a look at that. Now, another important thing, by default, if you log into firewall, let me log in. Start. Allow me a minute. Okay, the firewall is ready, so let's try to access it. So the password for Linux machine is root. Okay, 1.3 will be our firewall. So let's take a look at this. So by default, if we look into the firewall policy, we don't see all these 7 types of policies which we discussed. So let me go back to the policy section. So So under policy and object tab is where you will define your policy. So we have firewall policy, DOS policy, but I don't see any other policy types. So for our reference, so only the firewall policy and DOS policy is visible in the GUI as a default setting. So I don't see proxy policies, multicast, local in, DOS policy, okay, and there is no traffic. Okay, here we have traffic shaping policies. So we don't see any other options. The reason being these features are not being enabled. So where we can enable the feature on the firewall, so under system settings, and we have feature visibility. So this is where we will define what services we want to, what uh, what type of policies or what type of features we need to be enabled. So in this, so if I want to allow multicast, let's see. So we should have a feature for multicast. Okay, here it is. So if I want multicast, I will enable multicast policy, and once I apply, it will log me out. No, okay. And security profiles, sorry, policies and objects. And now we have multicast policy. So whichever policy we needed, based on the situation or the requirement, we will define it under our feature visibility page. Now let's come back to regular policy. Okay, firewall policy. Okay, so what are the how to create a firewall policy? Let's take a look at that. So from the GUI, the creating a firewall policy is straightforward. It's what we refer as a flat configuration. So we hit create policy, we get all the options, and then we will start filling in the details, and the policy is ready. But if we do the same from CLI, it's very different. And I wanted to differentiate one key feature, a key option here. Let me show the same from CLI side by side. So config firewall policy, and at the moment we don't have any. So let me create one. So if you check between the GUI and CLI, I haven't created any policy yet on the CLI or even in the GUI, but you see this UUID. So this is something that is automatically assigned, and it will change over time. Or but what is the reason for this UUID? This is anyway for administrators, it is very hard to remember or make use of it. So what is the purpose of this UUID? Even if I create a policy from a GUI and if I verify the same policy in the CLI, I will be having an UUID set. So UUID is nothing but a unique identifier, and the purpose of this ID is to fetch logs. So if I have, well, after creating policies and I allow the traffic to traverse through, now for all the traffic which has passed through the firewall, we have a set of logs being recorded. So all those logs, we have to fetch it in a much faster and reliable manner. So for that purpose, we will use this UUID. So in the backend, in FortiGate firewall, we are using an SQL server to fetch logs. So firewall will act as an SQL server where the logs will be stored in the disk, which will act as SQL client. And whenever we do a search, an SQL query will be passed to fetch the logs. So for that SQL query, we will, for the SQL database to be fetched effectively, this UUID will be used. This UUID will be tagged to all the logs when it is written in the disk, and using this, we can easily fetch the logs. Now let's come back to creating the firewall policy part. So first thing, this name, this is not mandatory, but it depends on the firewall setting. So there is something which we there's an option which we have to enable, which is advanced configuration. So once that is enabled, we can say whether this name is optional or mandatory. As a best practice, it's always good to name your policies. So let's say policy test. Now, this type field is introduced starting 7.2 or 7.4, where you have to decide between a standard policy or a ZTNA policy. So in ZTNA policy, you get the option to refer your ZTNA servers, and where you will also refer certain tags. But today's discussion is with the standard policy. The reason why we are not discussing ZTNA today is we don't have the ZTNA components ready with us in this lab. It was not prepared yet. So once we have the ZTNA components, we can have discussion on that. For ZTNA to work, we need 40 client and 40 EMS on those devices. It depends on those devices to assign tags. So next, the important thing is the incoming interface. So on which interface the traffic is going to come in. So this is an important definition which we have to provide. So this is a matching criteria. In fact, if you remember the 5 tuple values, interface is one of the tuple values. So interface definition is very important for the firewall policy to match with the specific traffic. Now, once we select the interface, let's say port 2 going towards port 3. Let me reference the topology. Port 2 going towards 3, 4. Okay. Port 3. Okay. Now in the source, I can either use an all filter, which will allow all the traffic, or I can use a specific address group. So yesterday we have discussed about this address group options. So if I have to create an address object, we have an option here to create. Let's try to create an address. Let's say the client machine is coming from 20.110/24. So let's add that subnet. LAN segment. And here we can specify an interface if needed. If not, we can leave it. And the subnet is 20 dot, let me check once again, 20.110/24. So now this policy will only allow this 20.0 segment. No other, if a PC comes from the same net port 2, if any traffic comes on port 2 and it doesn't have this 20.1.1 IP address, then the traffic will not be matching this firewall policy. And destination, we can either define a service or we can say all. And then comes the services. So schedule we will discuss later. So in services, we have all these predefined services in our firewall. We can either use these predefined services, or what we can do is we can create our custom services. We can also have a service group where multiple services will be combined, or you can create a service. Now in service, the options are very straightforward. We have to define the protocol, whether it's an ICMP, IP, or TCP UDP based protocol. Now, if I go with the IP protocol, I have to specify the protocol number. Now, this is beneficial in scenarios where you have to allow traffic based on the protocol number. For example, what we can say, let's say what protocol we can allow. Maybe if I select routing protocols, then those protocols firewall will be participating in it. Maybe let's say protocol number 1. This will allow only ICMP. But if I do, okay, let's consider this as an example. If I select protocol number 1 here, which is going to allow ICMP, now I don't get an option to control what type of ICMP packets I have to allow. But on the other hand, if I go with ICMP, I have an option to define type and code. So this is an important, I will say important function. So whether you want to allow the entire ICMP by just defining the ICMP protocol, or you can select the ICMP type and you can define the type and code. And then the TCP and UDP part where you can define an address range, IP or FQDN, and then you can define the ports here. You want to allow a set of a range of port or a specific port. So if I want to allow a specific port, I will be saying 80 to 80. So this will allow only this connection, or I can also say 80 to 443. So all the ports in this range is allowed. Now, we should be very careful when we configure an outside to inside policy, where if you're defining a service, be very careful with it, because if you allow a range of connection, then anyone can run Nmap scan and see what services are exposed. So we need to be careful when we use the same object in outside to inside configuration. And then specifying a source port, uh, this is not useful in every situation, but there can be certain scenarios where we can do this. So for the time being, let's go with service all. And then comes the schedule. So let's say you have a firewall, you have a backup server in your network, or you have a database backup that is going to run in your network. And we know for a fact it's going to be run at a specific time. Maybe let's say the backup is going to start at 1 a.m. and it will run till 5 a.m. or something off business hours. So in those cases, we can create firewall policies with certain schedule, and these policies will be enabled only on that particular time period. So rest of the day, the policy will stay disabled, but only during the specific time, the policy will be enabled. But the thing is, always be very careful about this schedule, because sometimes this can lead to network outage as well. By default, the schedule will have all day selected, but if by mistake, if you select a wrong day and if the schedule is messed, then certain policies will enable or disable depending on the configuration, and your traffic will be blocked. So this, if the schedule is not configured properly, it can cause outages also. So please be very careful with this option. And based on these factors, now we call this as a preliminary inspection or initial set of inspection, which the firewall is going to do to match a policy. Based on these these options, we can either allow or deny, accept or deny the connection. Now, if I deny the connection, fine, I don't have to do any more inspection, so no more options to configure. But if I choose to accept the connection, then comes the inspection mode, whether I want to do the inspection in a flow-based mode or proxy-based mode. Now, the difference between flow-based mode and proxy-based mode is in flow-based mode, the traffic is inspected on the fly. So as the packet comes in, firewall will inspect the traffic and then will send in. But in proxy-based mode, firewall will buffer the traffic. So let's say if a file is being sent through, and if we want to inspect the file in proxy-based mode, firewall will literally catch the file in its memory. If it's a 5 MB file, the file will be stored in the firewall's disk, inspected, and only if the file is safe, the file is sent in. But in the flow-based mode, there is no concept of locally storing the data. So as the file comes in, packet by packet, the file will be inspected and will be passed on. Now you can always ask the question which one is more secure? I have asked this question so many times, which one is more secure? So this has nothing to do with the security. Both the modes are secure, but the way the traffic is inspected differs. So when we discuss about the UTM profiles, we will get much clarity on this part, because for different UTM profiles, the flow and proxy based inspection will change. So once we discuss those topics, you will get some clarity here. So this NAT part, I believe everyone has a clarity here, because we have already discussed this. So based on the policy which we configure, the NAT will be applied, and this NAT is for the source NATing. This is not for DNAT, destination NAT. If I want to do a destination NAT, I will be referring virtual IP object, and I will be referring it in my destination field in my policy. And then comes the security profiles. These are what we call UTM profiles. For UTM profiles, I need a separate session to discuss so that the topic can be covered properly. So we are not discussing UTM profiles today. And the last option is the logging part. So how we want to log the traffic. Logging is very important for any enterprise network, because if something bad happens, we always want to go check the logs, what happened in the network. And if there is no logs available, then it is very hard for the engineers to work on. Now, we should also consider the performance standpoint when we log the traffic. For example, if you are working in a high throughput environment, and if you choose to log all the DNS traffic, now that is not very good for the firewall, because now firewall can receive like thousands of DNS traffic, and if all the DNS traffic gets logged, then the processes running on the firewall, especially miglogd as an application, which will always run with high CPU, because it have to write all the logs to the disk. So we need to choose what kind of traffic we want to log. So DNS is something which we don't have to log it and maintain the data. But if your organization policy requires it, then in those situations, you can always log DNS. But in those scenario, please make sure you're doing it on a higher end model. Please don't log DNS traffic in a lower end or a mid-series model. You'll be in a situation where the firewall CPU is running at 100%. And then generate log when sessions start. So if we enable this option, there will be two set of logs created. One, generally by default, a log will be created only when the session ends. But if I enable this option, I will get a log when a session is created, and I will get a log when the session is ended. So it will create two different logs. So based on this, let's apply this configuration. And it should be good to allow the traffic coming from that PC. Now we will generate some traffic, and we will see how the log looks in the firewall. We'll get back to that. But before that, let me also show how the other options available in this page. So by default, the view selected is interface pair view. So all the policies which I create for a LAN port, that is port 2 to port 3, will be grouped here. So if I create another policy, let's say test, let's say LAN 2 to port 3. Let's say source all. Now, the policies will be arranged in the order which I create. So the first policy which I created will be on the top, and the second policy is at the bottom. So when the traffic comes for matching, the matching will always happen from the top to bottom. So the first policy will be allowed. But it is always good to have the specific policies on top and the granular policy at the bottom. Now, in this case, the second policy is only going to allow ICMP, but it's going to match all client. But the first policy is going to allow only the LAN segment traffic, and it's going to allow all services. So you don't need two different policies for this. We can maybe combine these policies, but that's another topic for discussion. Now, how can we rearrange a policy? So rearranging a policy is very easy from the GUI than the CLI. In CLI, you have to type multiple commands to rearrange, but the easiest part is drag and drop option, which we have in the GUI. So simply drag and drop the policies, and the policies will get rearranged. Okay, let me bring it back to its original state. And let me show you something here. From the GUI, from the CLI, let's take a look at how the policy will looks like. Config firewall policy and show. So we have created two policies. So this UUID is something which we haven't created manually, but it's automatically assigned. And you see the first policy which I created, it is given the ID 1, and the second policy is given the ID 2. Now, these policies are now arranged in the order. Now let's rearrange the policy and take a look. So let me rearrange the policy. Okay, config changed. Now let's run the same CLI command once again, show. And now you see the policy 2 has came to the top and policy 1, that is edit 1 has come to the bottom. But these numbers didn't change. So these are what we call as policy ID. And you can verify this from the GUI also. You have to enable this option under configuration table, enable the ID to be visible. Okay, ID. And let's bring the ID here. So this policy ID is something that is automatically assigned, but if you enable advanced options, you get the option to choose the ID. Now, in this case, the IDs are assigned in an incremental manner, and the IDs, once it's assigned, it will never change. So even if you create a policy from the CLI, you cannot change an ID once it's created. So it stays there. You can delete an ID, but you cannot edit this ID number. You can delete this ID 1, and then you can recreate the entire policy with a different ID. That is fine, but you cannot change an existing ID because based on this ID, um, we will identify a policy, but this ID has nothing to do with the top-down approach. It's not like if the ID 1 is on the top, it will be matched, or ID 2 is on the top, it will be matched. So the position it's very easy to define the position from the GUI. So whatever policy is on the top, that will be matched first, and this on the bottom is on the subsequent level. Now, other than the interface pair, you can also have this by sequence view. So again, in by sequence, you are not going to see you'll be getting this source and destination interface as a separate option. So let me show you the difference once again. In interface pair view, the actual interfaces are being categorized here, so it's easy for you to look. The reason why we have this interface pair view is if you have the view set to sequence by sequence, you have the policies from all the interfaces being clubbed together. Let me create another policy, test2, and let's say instead of LAN2, let's say the traffic is going to come from port 1, and the traffic is going to go to port 3. Let me allow all services. All services. Okay, nothing much. Now, if the view is set to by sequence, now it is kind of hard for us to check which traffic is going to match. And if I decide to put it on top or in between, it'll be in times it will be confusing for us to say which policy is going to exactly match. But in this scenario, we can go with interface pair view, where the traffic will be grouped based on the interface where the traffic is going to flow from. So if the traffic is going to flow from policy 1 to 3, if it's not in our focus, we can minimize this and we can only focus on a specific policy which we want to work on. In short, based on this interface grouping, again, the top-down approach should be followed. So for any traffic going from port 2 to port 3, the top-down approach is followed. But for port 1 to port 3, it's a different grouping. So based on whatever groups or list of policies we have here, it will be used for the traffic matching. Layout is fine. It's just an option. Now there are multiple other options which we can enable, and some of them will be useful, especially the hit count. So this and the last used. This will give us an idea of when was the policy last used, and this will be very useful in times when you want to clean up your rules. So you can use the last used or hit count to take a decision on that. Now, if you focus here, under the logging section, we have two different options. One policy says UTM and the other policy says disabled. So what will happen in these cases? So if the log action is set to UTM, then only the UTM violation will be UTM logs will be generated. If there is no UTM profiles in the policy, there won't be any logs created. But if the log is disabled again, then no logs will be created. So let's edit this. So see, in this policy, it's not allowing any traffic. So if I enable this log allow traffic, then I will get an option to select between security events and all session. If I select security events, this is where only the UTM traffic will be logged. So let's say I have a web filter being enabled and there's a web filter violation that will be logged. But if I select all session, in this case, no matter it's a UTM traffic or normal traffic, it will be allowed. If I have to give another example, let's say I have set this to security events, and in the services, I'm allowing only ICMP. If I configure it this way, in services, I have only allowed ICMP, and in the logging, I have set to security events. Now, this ICMP traffic, it's a layer 3 traffic, so it's not going to go for any UTM inspection. We don't have to do antivirus inspection or the filter inspection on an ICMP traffic. So in this case, even if the traffic is allowed, it won't generate any logs. Only if I select all session, this ICMP traffic is going to be logged because the service allowed in the policy is ICMP and it doesn't go for layer 7 inspection. So depending on our requirement, if we wanted to if we want to log all the network traffic, then we can go for all session. Or if it's only layer 7 inspection traffic or UTM traffic, then we can go with security events. Based on the requirement, we can enable this option. Now, there's one more scenario I wanted to discuss. In this case, let's say for this firewall, this remote firewall, we have two ISPs, ISP1 and ISP2. And ISP1 is on port 4 and ISP2 is on port 3. Now, if we check the routing on this firewall, let's check the route. Now we have our default route pointing towards port 3. Let's see if we have a default route on port 4. We do. So what's different here? 15. Let's make it 10. Okay. So now we have two policies, two static routes in my static default routes in our routing table. But the traffic can go between port 3 and port 4. But the security policies which we have, let's check the policy. Now the security policy says the traffic is allowed from port 2 to port 3. Now for some reason, if our port 3 goes down, there is no policy to allow the connection on port 4. But our routing says the port 4 can also be used to reach internet. Now this is the problem which we discussed yesterday. So the policy has to be created based on our routing. So as per the routing setup, we have port 3 and port 4, which is used for internet connection. But as per my policy configuration, only port 3 is allowing this. So if port 3 fails, all the traffic will fail. Now I can create another security policy and say traffic coming from port 3 to port 4, sorry, port 2 to port 3 allow, sorry, port 2 to port 4 to allow this. Let me create this ISP policy. And let's say connection comes from port 2 and the traffic leaves out of port 4. Let's allow all service. Okay, so here is the rule which we created. Now we have created additional policy in the firewall. Now let's say I have like 50 policies created. If my network needs 50 policies to allow connections from my LAN segments or DNC to internet, and if I have three ISPs, then if I follow this method, I have to create 150 policies to allow any connection. So I am increasing the policy number from 50 to 150, and at the same time, I'm going to increase the load on the firewall. Now, firewall have to match through all these policies in top-down approach to match with any traffic. So that is not an efficient way. So what to avoid this situation, what we can do is we can enable another option from feature visibility. We have an option called multiple interface policy. So let's enable that. Okay, multiple interface policies. So let me apply this. So once I enable this multiple interface policy, you will see the difference here. Let's say I'm trying to create a policy. Now you get this option any, or you can select multiple interface. So this solves our problem. Now, because of this, we don't have to create 150 policies. So let me go back to my previous policy. So now we don't need this policy 2 to policy port 2 to port 4 policy. We can delete this entry, and instead we can come back to our original policy. Let's say policy test, and in the outgoing interface, I can define policy for the port 4 as well. Now this is going to match all the traffic coming from my LAN segment, that is port 2, and that goes towards port 4. Now you can ask the question why it created two different policies. It is because of the layout which we have selected. So if you remember earlier, I deleted this policy and then we edited this policy 1, but still it created two different policies, one from port 2 to port 3, one from port 2 to port 4. So this is because of the layout. If I go back to sequence, you will have one policy, that is policy test, and it says 1. It is from port 2 going towards port 3 and port 4. Let's check the reference. If I go back to interface pair view, I will have two policies with the same name. So this is an important thing to keep in mind. Don't get confused with this. So let's go with sequence. So now we have this policy. Let's put this, okay, port 2 to port 3, all services. Okay, this will allow only ICMP and this will allow all traffic. Now we have the policy in place. Now let's see if we can send some traffic, and let's take a look at the logs. So let's access this PC. Okay, before that, let's try to generate ICMP traffic. So let's see. So we are receiving destination host unreachable. So let's see if we are receiving the traffic on the first PC. So let's take a look at there. Now let's say we have multiple policies and we don't know which policy is going to match for the traffic. So we have this option policy match where you can put in the details. So we know that this traffic is going to come in port 2 and it's going to use the protocol ICMP because I am generating ICMP traffic now. So ping request, ping reply, or other you can define. Let's say ping request. And let's say the source IP here is 20.1.1. What's the IP? So the IP address of the machine is 2112. So let's use that as a filter and check 2112, and destination is 8.8.8.8. So user, we are not using any user authentication. So let's say to any, and let's see which policy is going to match this traffic. So this is going to match test 2. So that's the policy that is going to allow this connection. So that is the one which we have on top. So using this policy match option, you can check which policy, whatever policy you have configured, you can decide which one is going to match. Now, in this scenario, we are receiving the traffic, but it says destination unreachable. So we are receiving the traffic on port 2 was R35002. So echo request is never forwarded out. Okay, again the ARP issue. Okay, NAT is enabled. Okay, I think the upstream configuration. One moment. Port 5 and 6 to port 2. Let's see if we have a policy. Okay, we have an any which will allow this. This is 35.0. This is 35.0. I keep on confusing with these octets. Okay, so the gateway is reachable for us, but when we do ping for 8.8, it's not working. So what the sniffer says is, so we received all the requests, but for some reason, ARP issue, we are not forwarding it out. Let me check. Let me enable this option and show the logs real quick. Generate log at session start, all session. Okay, let's take a look at the log at least. because we are running on short on time. Forward traffic. Okay. So once we come to forward traffic, this is what our logs will look like. We have a much more detail like about the traffic, and we also have this UUID. So this based on this UUID, logs can be filtered easily. So sometimes you don't have to from the policy and object page, from the firewall policy page, you can directly view the logs. So you have this option show matching logs. So that will directly take you to the a policy page, and with the UUID you'll be filtering the logs. So based on memory, okay, what happened? So you can select the logs, and then you can also check here. So if we have UTM enabled, then we will also get details about the UTM here. So under security, you will get the details about UTM shown. Okay, so the time is already 10 p.m. Sorry, 10 a.m. So we can end the session here, and I will use another 5-10 minutes to do a question and answer session. So if you have any questions, please feel free to put it in the chat, and I will try to answer. Okay. So we have multiple routes, so gateway has to be specified. This is 46.1. Let's see what happens now. Okay. So once we specify the gateway, now we have request and reply. So let's check some UTM logs also real quick. In the meantime, please put in the questions if you have any. So this is our remote PC. So let's say google.com. So we have google.com access. Now let's check the logs from the firewall. So let's come back to login report and forward traffic. We should have all the traffic for google.com here. So now we can see the DNS request going towards 8.8, and that is for google.com, and then we have see that actual traffic going towards google.com. So we don't have any UTM profiles applied. That is the reason why we don't see any security level logs here. But if you have UTM actions applied, then we will see the actual UTM action taken. So for UTM logs, we will discuss this in the next session, because I want to differentiate between different UTM profiles and how the logs will look like. So that needs more time. So that's the reason why we have kept today's session short. So we will have much more detailed discussion for UTM in our next class. Okay, that's all from my end. So if you have any questions, please feel free to drop it in the chat. We will discuss. So Dinesh have this question. Are we covering HA in this bootcamp course? Dinesh, I can try to cover HA, but before HA, I wanted to cover some of the basic topics. So that is taking more time. So on the last day, I will try to cover HA. I will give a brief intro on that. Okay, Ramya, VDOM topic. Okay, VDOM, it needs more time, but yeah, we can have a brief intro on VDOM as well. So basically, VDOM is nothing but segmenting your firewall into multiple firewalls. So at the moment, this particular VM, this particular firewall is acting as one firewall. Now under system settings, I have an option to enable VDOM. So once I enable VDOM, one moment. So it will be tucked away somewhere here, like which says virtual VDOM. So once we enable the VDOM, you have an option to use multiple VDOMs. Let me check the license for this. So currently we have virtual domain configuration disabled. So once we enable this, we get the option to configure VDOMs. So basically, it's splitting your firewalls into multiple firewalls. So Vignesh, show default policy on FortiGate is implicit deny. Yes, Vignesh. So by default, the first policy you have on the firewall will be implicit deny. So this is that policy. So and there is no logging enabled for this. If we need, we can enable logging. So only if we enable logging, you will get logs for this. By default, there is no logging. So yes, deny policy is the default policy. So, Shihab, is there an advanced topic course planned following this? Yes, Shihab, there is an advanced course being planned because there are so many features we want to discuss and it needs a lot of time. For example, user authentication. User authentication itself is a separate topic. Then if we go to VPN, we have our standard IPsec and SSL VPN. But on top of that, we have AD VPN. That itself needs a longer time to discuss. So yes, there is an advanced course being planned. So Raghav asked a question, do you have any topics on firewall hardening against best practices for security? So firewall hardening, there's a separate guide out there, but as a course, I can say what are the best practices we can do and we cannot do. So if it comes to policy, then I can say we have to define the services very specific. We should not expose our services to the internet. But when we discuss certain topics, we can discuss the best practices, but it's not planned as a separate topic. We can see that Rajesh has a question. Did we see the traffic hit count on the policy that we created? So let's check that. We have some traffic, so let me enable that option. Okay, we have this in our interface pair view created. So let's check. So here is our hit count. Hit count last used and the amount of traffic being sent. Now the reason why the second policy has last use as 42 seconds is it has ICMP allowed. All session. Okay, the first one has ICMP allowed. So we get this hit count also, hit count metric, and also the amount of traffic being sent out. This can be useful sometimes. Now, for example, if a policy, let's say you have created a policy and if it's not taking any hits, then you can consider optimizing the policy or rearranging the policy. For those options, we can make use of this. Okay, Raghav, any reference for hardening in general? So general hardening practices, we should not expose our firewall in our WAN interface on port 443 or port 80. You have an option to define your services under system settings. If you check, you have this options to define on which port you can access your firewalls. So instead of using standard ports, you can change the ports. You can have your own custom certificate being used for to access the firewall GUI page. And then under administrators, we can use our if I am creating an administrator, I can enable two-factor authentication and I can also use trusted host. So only from certain IPs, I'll be allowing the admins to log in and take access to firewall. Now, in terms of policy, it all depends on the services which we are allowing. But if it comes to network interface, we should not enable all the services in our WAN interface. If in this case, I'm using port 3 and port 4 for WAN interface, ping is fine. But if I enable HTTPS or any other protocols, let's say if I enable HTTPS on the traffic on this interface, anyone on the internet can scan my network and can see 443 is open. And if they see 443 open, they will keep on sending DOS packets. So these are the basic things which we can check. Now, other than these are the hardening checks for the firewall. But if you're asking for a hardening check for the entire network, it depends on the scenario because there can be situations where you wanted to expose your some of your internal servers where you want, let's say you're configuring a web object and you want them to be accessed from internet. So in those cases, what we can do is we can configure DOS policy to restrict the number of connections to our server, but we need to know what's our benchmark, how much traffic we normally receive in our network. Only then you can define the DOS limit. Then you can make use of UTM profiles. So once you enable UTM profiles, we have all these profiles. They will help you in detecting malicious traffic and stopping them. Raghav, in the detailed course, I will touch base on this topic, and whenever we discuss each specific topics, we will discuss the best practice also. So, Vashant, what is proxy policy? Can you give a little overview? So, proxy policy is some okay. So, in the regular firewall policy, if I create or if I can use an existing policy, let me show you. So, in proxy policy, sorry, in regular policy, on the interface in the source column, we have an option to specify users. So I can say user and I can create a user or user group. I can create a local user and I can use them as a reference. So if the user is authenticated, then the user information can be used to match against a policy. But what if the user is not authenticated? I won't be able to those particular users traffic is not allowed. But if it's a proxy policy itself can trigger an authentication for that user and then allow them. So let me enable the feature. One moment, system feature visibility. Explicit proxy. And another important thing about explicit proxy is, let's say, let me go back to link pad. So let's be real quick. So in a regular firewall policy, your traffic comes in, firewall does the inspection and the traffic goes out. So your source IP will be the client PC and the destination IP will be the server and the server will be somewhere on the internet. Now this is for the regular policy. But if you talk about proxy policy, your source IP will be client, your destination IP will be the firewall. Because what happens is on your client PC, you have the pack file. This pack file will, instead of sending the connection to your actual server, it will send all the connections to your proxy IP. And this proxy will be something on the interface. So what happens is instead of sending all the connections in 443, so let's say your original server is running on 443, Instead of accessing all the connections on 443, if the pack file and if the firewall is configured for proxy, maybe your connections will run on port 8080. So connection is not encrypted for the firewall. So your firewall is, and if you want to apply UTM inspection in this case, firewall don't have to perform decryption. The traffic itself is decrypted. Your client is not encrypting the traffic for the firewall. Your client will send all the traffic in plain text for the firewall. Firewall will do the inspection, and when the firewall forwards the proxy traffic out, when the actual proxy traffic leaves the firewall, the connection will be switched back to 443. And how firewall knows that it has to switch the connection to 443 or 80 or maybe some custom ports? On the HTTP header, this information will be embedded. On which port you're trying to access, what service you're trying to access, this information will be embedded in the HTTP header. Since the traffic is not encrypted, firewall will be able to read this, and it will inspect and then sends out. When it sends the traffic out, it will convert the port number. So it needs more time to explain and discuss. We will cover this in our detailed course. So Raghav, can you unmute me? Raghav, we will come back on that. Rajesh, did we block the traffic that have certificate issue? Example, if domain did not have valid certificate, can we block it? If yes, what is the category? Which category we can block that? Okay, so certificate blocking is something that comes under your UTM profile. So if you check, we will discuss this in detail next class. So if you check this SSL inspection profile, by default it's selected as no inspection. But if you check all the inspection profiles available, you can create any new one, and here you can see whether you want to allow your blocked certificates. So there are list of blocked certificates, and this list will be coming from FortiGuard server. And then again, if there is any untrusted certificate, or do you want to do a SNI check? So based on these options, certificates can be allowed or denied. But there are certain categories which are exempted from SSL inspection. So in any websites that is related to finance and health and personal privacy, by default, these traffic will not be decrypted by the firewall. But if you want to remove it, you can remove it. But it depends on the country you're operating. If the firewall is deployed in UK, the law there is that the DPDR law, the privacy law is much stricter in UK region. So it depends on the country where the firewall is deployed. So guys, we are well past the time. So if there is no other question, let's drop the session. And in the next session, we will discuss much more details about the security profiles and how each profile will be handled and how the profiles will change for flow mode and proxy mode. The behavior, the way the firewall inspect the traffic changes. So we will discuss those things in detail in our next session. And once again, thank you all for your valuable time on a Sunday morning. And thank you and have a good day.